Dear students, greetings for the day. Today we will study about ground de-icing operation. Aircraft ground anti-icing procedures serve three purposes: removal of any frozen or semi-frozen moisture from critical external surfaces of an aircraft on the ground prior to flight, and/or protection of those surfaces from the effects of such contaminant for the period between treatment and becoming airborne, and/or removal of any frozen or semi-frozen moisture from engine intakes and fan blades, and protection of external surfaces from subsequent contamination prior to takeoff. It should be noted that fan blade ice, which may be accumulated after the pre-start visual inspection, including whilst the engines are running at low thrust prior to takeoff, is removed by following prescribed engine handling procedures. First of all, the aircraft must be inspected for signs of contaminant already adhering to surfaces, and where found on surfaces which must be free of contaminant, it must be removed using a suitable ground icing fluid. Secondly, the prevailing weather conditions must be assessed. If further adherence of contaminant to the airframe surfaces is currently occurring or anticipated prior to the time at which it is expected that the aircraft will get airborne, then a suitable ground anti-icing fluid should be applied. In both cases, the time after the start of fluid treatment from which protection is provided by the fluids applied depends upon the prevailing conditions. The fluids are designed to shear off the aircraft surfaces to which they have been applied no later than the point at which the aircraft becomes airborne. The aerodynamic effectiveness of an airframe requires that an aircraft becomes airborne with critical airframe surfaces free from contamination by frozen or semi-frozen deposits, contaminant. This is called the clean aircraft concept. Failure to remove contamination from an airframe and/or to protect it from acquiring further contamination before it becomes airborne may result in sudden loss of control at or shortly after takeoff. In the case of aircraft with rear-mounted engines, any ice on the inner wings of an aircraft at takeoff may be shed and ingested into the engines, causing a partial or total loss of thrust. In respect of engines, frozen deposits within the intakes, including on the fan blades of jet engines, may detach and be ingested by the same engines during the subsequent application of takeoff power, with the attendant risk of adverse effects on engine performance during the potentially critical stage of initial climb, including the possibility of engine flameout. The difficulties of reliably ascertaining the contaminant status of the aircraft because of a lack of suitable access equipment and/or the absence of adequate external lighting at night. The need for flight crews to rely upon assurances from other persons that their aircraft is free of contaminant after treatment at off-gate or remote sites. Deterioration of the properties of the anti-icing fluids due to failure to store them correctly. Inadequate anti-icing service at smaller airports which do not regularly experience icing conditions. This may be because of the use of ground staff multitasking and their consequent infrequent application of the tasks for which they have been trained. Complacency by flight crews not routinely encountering conditions requiring ground anti-icing in respect of frost on critical swept wing surfaces. To protect against loss of control, the following precautions should be taken prior to flight in weather conditions which are or have recently been conducive to ice accretion. A thorough inspection of all the airframe critical surfaces to establish if any existing contaminant is present. The prevailing surface temperature of the aircraft skin is as important as the prevailing outside air temperature. A consideration of the weather conditions which prevail, and are likely to prevail, after the start of any treatment device already on an airframe to determine if anti-icing is necessary. The correct application of appropriate airframe de-icing fluids and/or anti-icing fluids and the correct use of the anti-icing code to help prevent any misunderstandings. The determination and monitoring of the applicable hold over time, hot, by the flight crew so that takeoff is not attempted if it cannot be completed within that time. It is important to note that the applicable hold over time may change if prevailing conditions change. Not taking off if there is no applicable hold over time for the weather conditions which have prevailed at any time since the commencement of ground anti-icing. This applies for heavy snow, hail, defined as ice pieces between 5 and 50 mm diameter, snow or ice pellets, defined as hail of less than 5 mm in diameter, and moderate or heavy freezing rain. Care to reduce holdover times if the effect of either jet blast or high wind speeds indicate that this would be prudent. If an turbine engine aircraft has been exposed to frozen deposits whilst parked on the ground prior to intended flight without having blanks, covers fitted to engine intakes, detection of snow or slush within the engine is likely to be impossible using normal visual inspection, and removal of contaminants equally difficult, so qualified engineering assistance should be sought. For this reason, every effort should be made to prevent the ingress of snow, rain, etc. by the use of engine inlet covers and blanks. All flight crew and all other persons involved in the inspection of aircraft for contaminants and the application of ground anti-icing fluids should receive initial and recurrent training on the subject. Every MOPOS should contain comprehensive and up-to-date information for flight crew on ground anti-icing, with special attention being given to incorporation of the latest holdover time, hot, tables. Effective quality control procedures should be in place to ensure that proper procedures for the delivery of ground anti-icing by service providers exist and are followed. In addition, aircraft operators should ensure that quality assurance procedures cover ground anti-icing. The anti-icing code should be used at all times to communicate and record the details of the aircraft treatment carried out to avoid any misunderstandings. If the post-anti-icing check is incorporated into the de-icing/anti-icing operation, suitable time should be available to allow for the de-icing steam to disperse to ensure that the de-icing operator has good visibility to conduct the post-de-icing check. Lighting should also be effective and serviceable for night operations. Use of thickened Type 2 and Type 4 ground anti-icing fluids has sometimes resulted in fluid residues accumulating in aerodynamically quiet areas of the external airframe structure, particularly in the gap between the leading edge of the elevator and the horizontal stabilizer, and also in the gap between the leading edge of the ailerons and the wing structure. When this residue is subsequently rehydrated and then exposed to sub-zero temperatures in flight, it freezes. This results in primary flight control restrictions on aircraft types such as the BA 146/Avro RJ series and the DC-9/MD 80/90 series, which have at least some unpowered flight controls. After a number of serious incident reports, many operators of affected aircraft types have adapted their aircraft maintenance procedures to carry out appropriate inspections and residue removal when these fluids have been applied. PRM-1, France. On the 4th of March 2013, a Beechcraft Premier 1A stalled and crashed soon after takeoff from Annemasse. The investigation concluded that the loss of control was attributable to taking off with frozen deposits on the wings, which the professional pilot flying the privately operated aircraft had either not been aware of or had considered insignificant. It was found that the aircraft had been parked outside overnight and that overnight conditions, particularly the presence of a substantial quantity of cold-soaked fuel, had been conducive to the formation of frost and that no airframe anti-icing facilities had been available at Annemasse. C-208, vicinity Pelly Island, Canada. On 17th of January 2004, a Cessna 208 Caravan operated by Georgian Express took off from Pelly Island, Ontario, Canada, at a weight significantly greater than maximum permitted and with ice visible on the airframe. Shortly after takeoff, the pilot lost control of the aircraft and it crashed into a frozen lake.